Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the POQ discussions on JEE advanced papers. Today I have got a problem from JEE advanced paper 1 2023. Let us read the problem and try to solve it. So this problem says a plane polarized blue light ray is incident on a prism such that there is no reflection from the surface of the prism. The angle of deviation of the emergent ray is delta is equal to 60 degree, which is shown in the figure. So this is the blue light, there is no reflected light here, and the angle of deviation from the other surface is shown 60 degree. The minimum angle of deviation for red light from the same prism is 30 degree, which is shown in the figure 2. The refractive index of the prism material for blue light is √3. Which of the following statement is or are correct for this problem? So the options are here. The blue light is polarized in the plane of incidence. Second option says the angle of prism is 45 degree. Option third says the refractive index of the material of the prism for red light is √2 and the angle of refraction for the blue light in the air at the exit plane of the prism is 60 degree. So look here, you may have more than one answer correct. So you have to see all the options and verify whether the option is correct or wrong, and then you have to tick all the correct options. So let us try to verify the first option, that is the blue light is polarized in the plane of incidence, whether this is correct or wrong. So here some clues are given. See, first clue is blue light is plane polarized. Plane polarized means, see, before we solve this problem, let us little bit recap about polarized and unpolarized light. So an unpolarized light will have electric vector oscillating in all possible directions that you know. So representative unpolarized light we take with the light vector which is oscillating in plane and out of plane. So when I say a blue light is plane polarized, then I'll have the light vector which is oscillating either in plane or perpendicular to the plane. So here in this case, see, when an unpolarized light incidence at the interface of two media, suppose this is air and this is some medium having refractive index mu, then if it is unpolarized light, there will be a particular angle of incidence which is called angle of polarization. At this particular angle of incidence, there will be a reflected ray which is fully polarized with the light vector which are perpendicularly oscillating. That means the reflected ray contains the light vector which are oscillating only in the plane perpendicular to the plane of the paper. And there will be a refracted ray also. So that will contain both the light vectors. That means the refracted ray will be partially polarized light. Okay. So this is happening in general when an unpolarized light incidents at the interface of two media. Okay. At this condition, Boost's law said tan theta p is equal to mu. So this also will be using for solving this problem. Before I go to that, let me tell you, if there is no reflected light at all, then what does that mean? That means that light ray is polarized in the plane of the incidence. Okay, so that is what we can say. Otherwise, there will be reflected ray. So the condition for reflection or condition for obtaining a reflected ray for a plane polarized light is that if the incident light is polarized out of the plane of incidence, then only you will get reflected ray. Otherwise, you will not get. So in this case, we are not getting any reflected ray. So we can say the light is polarized in the plane of the incidence. So the first option given here is absolutely right. So second, we have to find out what is the angle of prism. See, for finding out angle of prism, we know there is a formula. Delta is equal to I plus E. I means angle of incidence. This is E means angle of emergence minus A. But both of these we don't know. See, to know this, at this interface, I have to apply Boost's law. So from there, we will get, see, tan theta p is equal to root over 3. That means what? This implies theta p will be 60 degree, or angle of incidence, if I just draw the perpendicular here, so angle of incidence will be 60 degree. Okay. Now I don't know what is angle of refraction here. Okay. So this is angle of refraction R1, and this is, suppose this is the perpendicular here. So this will be angle of refraction R2 here. So this R1 and R2 generally becomes same. Okay. Now how to find out this R1? So to find out R1, I'll apply Snell's law at this particular interface. So I can write, see, at this interface, I know the angle of incidence. So in air, the refractive index is 1, angle of incidence is 60 degree, is equal to the material has the refractive index root over 3, and this is sine R1. So we know this is root over 3 by 2 is equal to sine R1, 1 over root 3 will come here. So this will be sine R1 is equal to half. So this implies R1 is equal to 30 degree. So R1 is 30 degree, that means R2 also will be 30 degree, that is for sure. Now I can apply, see, this angle delta is actually angle of deviation, not the angle of emergence. So angle of emergence is this one. Okay, this I have to find out. So how to find out that? If I know the angle of incidence here R2 I know that is 30 degree. So I can apply again the Snell's law for this interface, emerging phase. So there I will write Snell's law, root over 3 sine R2 is equal to refractive index of 1 for the air, and this is sine E. Write sine R2 is equal to 30 degree, and this is sine E. So this will give you root over 3 by 2 this side. So E will be actually 60 degree. So see, there was a question here, like one option was here, the angle of refraction for the blue light in the air at the exit plane of the prism is 60 degree. That means this is E. Okay, so this is also correct option here. So we have got 60 degree. Now see, I have to find out what is angle of prism. From here now I will be able to find out. See, I is here nothing but theta p, which we have found out 60 degree. Okay, now we have see, delta is equal to 60 degree. Again E is equal to 60 degree. E is equal to 60 degree minus A. Okay, so and delta is also given as 60 degree. So 60 here, 60 degree here, plus another 60 degree here, minus A. So 160 degree will cancel from both sides, and so A will be 60 degree. So angle of prism is 60 degree, not 45 degree. So look, this option B is not correct. Now we have to verify the third option. So for the third option, we know the angle of deviation, minimum angle of deviation is given. Now the life is very simple. If the angle of deviation is given and minimum angle of deviation is given, and if the angle of prism is known. So angle of prism, now we know this is 60 degree. Angle of deviation, minimum angle of deviation 30 degree. So we have to find out what is the refractive index of the prism for the red light. So this is mu is equal to, we'll just write the formula, A plus delta minimum whole divided by 2 divided by sine of A by 2. Okay, so we know all of them. See, A is 60 degree, delta is 30 degree, so 90 by 2, that means sine 45 degree, and sine A by 2 means 30 degree. So this gives you root over 2. Okay, so look, the third option is also correct for the given problem. Okay, so I have got A, C, so answer will be A, C and D are correct. A, C and D are correct. Okay, so this is the answer for the particular problem. Thank you.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.